My name is Bob Thorne and I'm a Senior Applications Engineer here at Radan. And I'm here today to tell you about Radan's new release of CAD/CAM software, Radan 2016. Now on screen you can see a list of the highlights of this particular release. And during this presentation I'll go through each of these and give you more information about the new features and functionality.
Radan 64-bit. A dedicated 64-bit installation DVD is now available for installation of Radan CAD/CAM systems. Previously, you have been able to run Radan on a 64-bit operating system. However, your Radan would have been operating in 32-bit mode. In Radan 2016 there is a full 64-bit version. This means that Radan can take full use of the power of a 64-bit operating system. The benefits of running a 64-bit version of Radan on your 64-bit operating system are: you can access more memory, you can then open larger drawings and assemblies, and Radan drawing and symbol thumbnails will be displayed. 2D import options. The 2D import options have been extended to allow more detailed mapping of input geometry to output geometry. We have introduced a new Mappings tab which allows the user very precise control on how DWG and DXF files are imported into Radan. Examples of its use could be: ignore anything that is blue, convert any red geometry on layer Etch to Pen 5 full line type, or draw chain and dashed output line types as individual line segments. This extended mapping is shown on a new Mappings tab. Any number of mappings can be added. The listing order is significant as mappings should be listed in priority order. If a feature matches two or more mappings, one property is more important than the other, i.e. layer trumps pen and pen trumps line type. Let's have a look at this in action. Here in Radan I am going to open a DWG file using my default 2D import template. And you can see here the drawing contains lots of unwanted elements. In this case I've got an unwanted title block and drawing border. These lines have come across as full and red in colour. The outlines are orange. And here this line has the same colour as the outline. And here the text is in yellow. I am now going to open the same DWG file, but this time I will use a 2D import template that has multiple mappings on the new Mappings tab. And as you can see straight away we get a different looking the drawing no longer has a border and title. These lines are now a chain line and drawn in yellow. These outlines are now drawn in green. And this line is no longer a single line but multiple line segments which are drawn in the colour of my Etch pen. And then finally this text is now drawn again in the colour of my Etch pen. Let me show you how using the new Mappings tab I was able to control the import of this DWG file. Here we see the Mappings tab, and if we double click one of the entries we can actually edit its content. In this case we are looking just at this layer name. And we're asking the system to ignore entities on this layer. In this case, I am looking at just the layer title ISO, and again I'm asking the system to ignore any items on this layer. On this case, I'm saying any layer, but with geometry that is colored red. I am saying convert to a yellow pen, i.e. my pen 7, and make it a chain line type. Here in the input section, we are looking at all layers but only entities colored yellow. In the conversion section, we are saying convert these entities to a blue pen, i.e. pen number 5, and a full line type. We can add as many mapping lines as we require. Simply click the Add button and I can add a new mapping line. Here in the input section, I am saying look at all layers for any entity colored cyan. And in the conversion section, I am saying convert these entities to a pink pen, in this case pen 6, and make it a dashed line type. This new Mappings tab really does give Radan users a great deal of control on how DXF and DWG files are imported into Radan. (3D) import. When we release a new version of Radan software, we try to ensure that the 2D and 3D import and export file formats are as up to date as possible. The following will show you which file formats are supported in Radan 3D 2016. This column shows the 3D import file name. Here you can see the 3D file extension. And this column shows the minimum and maximum version of this file type which can be imported into Radan 2016. When we import 3D data into Radan, we do this where possible using our own conversion software called SolidLink. This column shows which files are converted with SolidLink. This column shows which file types can be imported using the core Radan software. When Inventor or SolidWorks update their software, there can be a delay in SolidLink keeping pace. If this happens, there is a backup method ensuring you can get the data into Radan. This column shows that this backup import option does exist for these file formats. This column shows that if there is material information in the 3D model, we can extract it for these file formats. case of Autodesk Inventor, the translation can be done using a component from Autodesk Apprentice, which is installed with Inventor and their free viewing software Inventor View. This means that when a new version of Inventor is released, but SolidLink hasn't been updated to support this version, Radan 3D will still be able to import the model if the new Inventor View software is installed on the system. A similar process can be used for SolidWorks. With this box ticked, the 3D importer will use either Autodesk Apprentice or SolidWorks equivalent when importing either of these file types. Here we can see the 3D import options where we can specify that we would like to use the alternative import method. 3D export. The following formats are supported when exporting 3D models from Radan 3D. Here we can see the file names, the file extensions, the minimum and maximum versions of this file that we can export, whether exported using SolidLink or exported using Core Radan. And this column shows whether or not material is exported with this file format. "3D Side Panel". In Radan 2016 we have added the 3D Side Panel, which enhances the editing and manipulation of models in Radan 3D. With the 3D model open in Radan, select this new icon to turn on the 3D Side Panel. Here we can see all the parts that make up this 3D model. By expanding the side panel, we can see additional information regarding each part. By right-clicking over a part, I can perform a range of edits. In this instance, I have turned off the visibility of the selected part. By selecting the visibility column, I can clearly see which items are or not visible. By using invert selection, I can isolate a part to work on. If I pass this part through to Radbend, you will see the Radbend status icon appear in the Radbend column. Open Profile Lead-ins. Automatic tooling now allows the user to specify a start condition to open profiles. In the automatic tooling dialog, a new page shows the parameters to specify the details. Here we see a part that contains some open profiles. Here in my auto tooling dialog you can see the new open profiles option. Here we can specify the details of lead-ins on our open profiles. Here is the lead-in on my open profile. I have assigned a thicker pen to my lead-in cutting condition to make it easier to view in this instance. Sheet scrap cuts. Start conditions can also be set for sheet scrap cuts and offcuts. Here we can see the area on the dialog that allows us to specify the lead-in parameters. I am going to add an offcut and a scrap cut to this nest. In Radan 2016, I can add a specific start condition for both offcuts and scrap cuts. Here we can see the start condition for the offcut. And here we can see the start condition for the scrap cut. Auto tooling pens. In automatic tooling, all pens and their associated actions are now shown and managed on one single page in the automatic tooling dialog. Here you can see the new pens dialog. In Radan 2016, in the auto tooling dialog, we have modified the pens page to allow editing of all pens and their associated actions. By clicking on a pen, I can select its action. Here you can see I've selected to ignore the features. Here, by clicking on pen number 4, I can specify that features of this pen should be fly cut, and I can set the cutting condition associated with this. Here I'm clicking on pen number 5, and you can clearly see that features of this pen will be etched. Of course, all of these settings can be saved back to your manufacturing database. Cutting conditions. Areas in Radan where the user can select or specify a cutting condition now show a more meaningful list of options. In Radan 2016 you will see wherever there is a requirement to specify a cutting condition, the drop-down menus will offer a more meaningful list of options. Note, only relevant cutting conditions will be displayed. Profiling, head lift. When avoiding hazards in profiling, there are two ways to do this. You could keep the laser head down and work out a safe route around the hazard, or you could stop, lift the head, move over the hazard and then lower the head. Both of these methods are time consuming. In Radan 2016 we have added a third option. On machines that are capable we have added support for the so-called ping pong move. This is where all axes of the laser head work together to find the quickest way to avoid the hazard. Here we can see a normal stop and lift. Here we can see the new ping pong lift in Radan 2016. In the machine configuration editor, there are two items of system data which allow you to control this ping pong lift. Interactive auto tooling. In Radan CAD/CAM 2016, a new automatic tooling mode has been in. This new mode is the default mode when the user switches to tooling mode. Pressing select all will auto tool the part or nest without any more interaction. Interactive auto tooling works with punch and profile. So let's start with punch. I'm going to auto tool this part in the usual way. You can see in this central area, if I leave the tooling as it is, I'm going to have a large area of floating scrap. I will delete this tooling in this area. In my auto tooling dialog box, I will change my tag options. I can now simply click on this profile using the interactive auto tooling option, and you can see I've now tagged in that scrap. Let's tool the same part, but this time with a laser. Here we see the part auto-tooled in the usual way. On close inspection, I should have used some smart ordering leads. I also don't want these pieces of scrap to be tagged in. To correct this, I can window delete the area that I want to change. I can then modify my auto tooling settings. I can now interactively auto tool these holes by dragging a window around them. Here's a little tip. In auto tooling mode, the select all button will add tooling to the whole part. Likewise, in delete mode, the select all button will remove all tooling from a part. New setup sheets. In Radan 2016 we have introduced a WYSIWYG report designer. It is now possible for users to design their own custom setup sheets. Going forward, we intend to extend this functionality to other areas of Radan CAD/CAM, such as project nesting. The report designer that is used is a third-party component called Extra Reports by DevExpress. The reports can include graphics, charts, barcodes and QR codes, and the designer is easy to use with a short learning curve. On new installations, the new reports will be active by default. On existing systems, however, you will have to choose to enable them. To start using the new setup sheets, you must do the following. After installing Radan 2016, in the Machine Configurator Editor, go to Advanced, and in the key field type U106, and in the value field type Y for yes. This will give you access to the new setup sheets. In order to use the new setup sheets in Editor, you must enable it for each machine. So here, in the Machine Configurator Editor, I'm going to go to Advanced, and in the key field type U106, and in the value field set this to yes. You can now see I can use the new DevExpress setup sheet reports. To display the setup sheet, select Blocks and then select Setup Sheet Reports. And here you can see an example of a new setup sheet, including the graphics. And here we can see an example of a QR code associated to a part. You can select different setup sheet reports if you wish to use them from the pull down. If you wish to use the editor to modify the report, simply go to File, Edit, and you will place the current report into the editor. The new setup sheets can reference Radan attributes. The new setup sheets can also contain images and graphics. And as you can see, they can also contain barcodes and QR codes. Auto Order Editor. In Radan 2016, to simplify the creation and editing of auto order text files, we have introduced an auto order text editor. You can continue to edit your auto-order text files in the usual way. However, if you would like to try the new editor, you need to enable it. To do this, in Radan, go to Administration Tools, Configuration folder, and on this dialog you will see a new tick box called New Feature Preview. This will enable the auto-order text editor. So in auto order, when you go to edit your text, you now get two options. Edit text will allow you to edit the text file in the usual way. Using the edit option will start the new editor. To be able to use the new auto order editor, you must first enable it. Simply follow these steps. In File, Administration Tools, Configuration folder, select New Feature Preview. Here in order mode, I can select my auto order text file and edit in the usual way, or I can choose to use the new editor. Having selected the editor, I can now create a new auto order text file. Hopefully you will see this is a very quick and easy way to create and edit auto-order text files. But as it is a feature preview, we would very much like customer feedback. So please try it out and let us know what you think. I'm now going to run the file that I've just created and view the results. Raster to vector. In Radan CAD/CAM 2016, a new import option allows bitmaps to be imported. The resulting geometry can be imported as a new part or draw. Here we see a full color raster image, and below you can see the file types supported. On importing, the raster is simplified, and from this simplified image vectors are generated, and from these vectors we can create a Radan 2D or 3D part. Rasters can be imported into either the drawing editor or the part editor. In the drawing editor, simply go File, Import, Raster Image. In the part editor, simply go File, Import Raster Image. In the part editor, I will import a raster image and show you how it works. So I'm going to browse now for an appropriate file, and here you can see the file types supported. You can see that immediately the raster has been simplified in preparation to convert it to vectors. There are a range of tools to help you modify this simplified image. You can see in this example, I've got some holes or white space there in my image, and here if I select this tool I can fill in those white holes. There is an options tab for greater control over how this raster is actually converted to vector. Once I am happy, I press the OK and I can convert this image into vectors inside Radan. And here we can see the geometry created. If I go into tooling mode, you can see that the geometry is closed and ready for tooling. I've now applied a laser profile to my geometry. If I copy this geometry and take it into Radan 3D, you can see that I can very quickly create a 3D part from this geometry. And here you can see my 3D part generated from my raster image.